Alright, so we have done this before. We've done parts 1 and 2 before. There are 4 total parts. We've done parts 1 and 2. We're going to learn a new part with part 3, and then tomorrow's part 4. You're going to have a homework sheet that has all of the parts on it, but you're only going to do certain things. Today's learning target says, I can simplify. Please let them in. If you got it, open the door. Don't act like you don't know how to open the door and then go sit down. Come on. I can simplify any radical expression. Any of them. Any of the parts. That's what we're going to be able to do by the end of this lesson. Now again, tomorrow is a notebook test. I would suggest that you have all of the things starting with page
56.
44. Nope.
Okay.
Oh, God.
43. 43 going through 56.
No.
If you don't have the things, you're not going to pass the notebook test. You have to be able to tell me the learning target on the page and give me an example justifying that you have mastered the learning target.
Oh, wow. Okay. Sounds good.
An example from the page.
Nah, I haven't decided yet. I may make you make a new one.
Meh.
Oh, then I better go home and get mine together.
I hear good things about that.
Yes, also, Sean.
Did you bring me a project?
I had page 2 from back in the day.
Did you bring me a project?
I print out the pictures. Again. I have it working on them. Football goes from 2 to 6.
I just talked to your mom last night.
I know.
Did you bring me that other homework sheet?
From last night?
And the night before.
We're supposed to turn the homework from the night before. No, you do something else. You just check
Yes,
it.
we put it in the tray. Alright, here we go. So, what you have to do, part 1, to simplify square roots. Remember, this is also like the worksheet that we did that you were allowed to get back and fix and then turn in. And some of you did, some of you didn't. Simplifying square roots means that you find the biggest perfect square that divides into that square root. So what do you think the biggest perfect square that divides into 80 is?
64.
Okay, so please do 80 divided by 64 and tell me what you get. Bottom right hand drawer. So that doesn't work, does it? It's got to be a whole number. So what do you think we should do next? That's not a perfect square.
49.
Alright, 49. I know that's not going to work.
36.
Okay, so please do 80 divided by 36 and tell me what you get. Of the desk. So that doesn't work.
25.
Okay, try 25. Tell me what you get. So that doesn't work. What should we do? 16 and 5.
I remember this.
Yeah.
Why are we doing it again? Okay.
Why do I have to teach y'all that 1/2 is the same thing as 0.5 using quarters? Okay. Alright, so what you do from here? Hopefully you remember, but you take the square root of the perfect square. What's the square root of 16?
4.
So your answer is 4 on the outside, and then 5 stays inside to read Harry Potter. Does everybody remember us doing this?
Can you do that next? I was getting calculated. Can we do that real quick, like?
Yeah.
You don't have to do it slow. I'm not 0.
So you do 80 divided by, it's recording, thank you for saying that. You do 80 divided by 16, and you get 16 and 5. You take the square root of 16 and get 4. 4 comes on the outside, 5 stays in
So
the
you
house.
just get whatever you got, the answer, and put it under with it. So yeah, I know. I'm good at it.
Okay, so again, you find the biggest perfect square that goes into 80. So we looked at our perfect squares, and for some reason y'all thought 64 would divide evenly into 80, and I don't know why. And then we went down our list, and we divided by 16. We got 16 and 5. 16 is a perfect square, so you take the square root of it, and you get 4. 5 is by itself, so it stays in the house. The reason that we take 4 to the outside is because we remember we need 2 of the same number to take the square root. So we have 2 4s, we take the square root of it, and it becomes outside. So 2 friends want to go play, they go outside, the one wants to stay inside and read Harry Potter. Let's look at 180. What's the biggest perfect? Okay.
How do you know that? So,
Because he can divide.
yeah, simple math. Right?
No, it's calculator.
We're just dividing.
Don't have calculators.
Alright, now what's the square root of 36? What goes on the outside? What stays inside to read Harry Potter?
$1 long at Subway for $5. Probably not a flip.
Please make sure you have a mullet, and please make sure you end the radical with a little hook.
Mullet? Okay. Okay, mullet. Engage.
Little Yachty.
Does everybody understand how we got 6 and 5? Alright, looking at this one, what do you think we're going to do here?
Multiply.
We're going to multiply what? So since both of these are under the radical, you can multiply them together. This becomes the square root of 28. Now, using our card, what's the biggest perfect square that goes into 28? 4 times what?
7.
Alright, now what do you think would happen if I added like a 3 here and a 9 here? What would we do with the 3 and the 9? You would multiply them together, and you'd get 27 on the outside. So go ahead and add that so that we can have that as a practice problem. Add the 3 and the 9, and then multiply them together and add the 27. They're on the outside of the radical, so you multiply them together. Just like underneath the radical, we multiplied 2 and 14. What are you confused on?
When you find the 4 and the 7, then you...
We're not there yet. We haven't taken the square root of 4 yet. Do you understand how we got to this point? Okay, so we did 2 times 14 and we got 28. And then we did 3 times 9 and we got 27.
Why did you do 3 times 9?
Because I wanted to add them so that you could see the difference between multiplying on the outside of the radical and multiplying on the inside of the radical.
What?
You cannot multiply. This is a radical.
I understand that makes sense.
This is the outside of the radical.
So what's the point?
This is the inside of the
Where'd you get
radical.
3 and 9?
I pulled it out of the air because I'm a wizard. Because I just explained that. I wanted to show you the difference between
So
what's
this
on
isn't
the
part of the
outside.
problem. This is just you helping.
We're adding it to the problem.
Why? What's the point of this?
To show you how to do it. Because we're going to have problems like this in our homework that you're going to have to do.
Bear. Okay.
All right, now, we have broken
Makes
down
sense.
28 into 4 and 7. Does everybody see where we got the 4 and 7 from? Because
Yeah.
4 is the biggest perfect square that goes into 28. What is the square root of 4?
2.
So what do you think we're going to do with the 2 and the 27? Multiply. Somebody remembers from last time. And 2 times 27 is 54. And what stays under the radical inside to read Harry Potter? 7.
That was confusing thing I watched like 6 years.
How was that
That
confusing?
doesn't make like why are you
Dude,
where
it's
did those
a
numbers
problem.
come from?
They came from thin
And why
air.
did you
They
multiply
came
27
from
and 2 out of the 4 numbers above it?
because you take the square root of 4, that's 2. 2 goes to the outside. There's already a friend outside. They multiply together. They make a baby. You get 54. Yes.
Why did you do it outside?
Yes. I take the square root of 4. I get 2. I multiply 2 times 27 and get 4. John, stop. That's weird. Now, you have a homework sheet that's going to look like this. I would like you to please do 1 through 6 right now as I bring it around. 1 through 9. 1 through 9.
Why?
Oh my God.
I can't even know.
1 through 9 is right now.
Is today perhaps the 11th?
It is.
Hey, what if I don't have my card for wait, maybe I do. I don't know.
I will put my card on the board if you don't have yours. Now, before we get to, I want everybody to pause and look at number 7. Now, number 7, do you notice anything different about number 7?
It has the number on the outside.
And then one of them does not.
Well, we just did that. So that's really not that much different. But what else is different about
One
number
has a
7?
number, one doesn't.
Oh my gosh. They're the same. They're the same radical. Can you stop talking while I'm teaching? Now, what you do is anytime you have the same thing right here, how we have 2 of the same radicals, you can multiply those together and it just becomes the number. So the square root of 5 times the square root of 5 is just 5. So now we have 3 times 5, and that gives us 15.
Understand.
The reason is, I'm going to, just hold on. If you take the square root of 5, and you multiply it times the square root of 5, that becomes the square root of 25. And what's the square root of 25? 5. So instead of doing this step, you just skip it, the radical disappears, it becomes the number. So what would the square root of 2 times the square root of 2 become?
4.
Is it 4 or 2? 2. Because it's the square root of 4, which is 2. So you can skip that step. What would this? Maybe pay attention instead of running your fingers through your hair. The square root of 3 times the square root of 3 is
3.
The square root of 9 times the square root of 9 is
9.
The square root of 7 times the square root of 7 is
7.
The square root of 12 times the square root of 12 is
12.
The square root of star times the square root of star is
Star.
The square root of smiley face times the square root of smiley face is
Brownie face.
Now please do 1, 2, 3, 4, 5, 6, 8, and 9. Real quick, go.
Okay, must do it.
How about we do 1, 3, 5, and 9?
What?
Do 1, 3, 5, and 9. Go.
Where's your card? Put card up, please.
1.
Thank you. Okay, let's see.
We just did the square root of 28.
So it'd be forward. And
Number 1, I got 2 root 7. For number 3, I got 6 root 2. For number 5, you multiply 2 and 10 together and you get the square root of 20, which then becomes 2 root 5. Number 9, I got 18 root 5. How many of us got them right?
skip the only one that I was talking about.
Woo!
Skip. We did 7 together. Are you joking?
No. Now, which part are we confused on and do we need to look?
7.
Number 9?
7.
You do 2 times, okay, that's what we just did. That is literally the one we just did. You do 2 times 3 and you get 6. 3 times 15, you get 44. 45. Then you break 45 down into 9 and 5. What's the square root of 9?
3.
What's 3 times 6? Boom. 5 stays inside to read Harry Potter.
Oh, here he is. 15. 15 is your answer for number 2? Okay, cool.
We did that one together.
Hey.
Alright, ready? Yes. Number 3. The biggest perfect square that goes into 72 is 36, and that gives you 36 and 2. And then the square root of 36 is 6, so it's 6 root 2.
Where'd you get 18 from?
Okay, so that's a great, what numbers did you use?
9 and 8.
If you use 9 and 8, there is another perfect square in 9.
3.
So, I meant 8. I needed a second to breathe. So you have 72, and you get 9 and 8. Now there's another perfect square in 8. It's 4 and 2. So the square root of 9 is 3. The square root of 4 is 2. So then it's 3 times 2, which gives you 6 root 2. So you have to keep breaking it down. That's why I suggest use the biggest one.
Where'd you get 18 and
Dude, we just said that. We just said that. 2 times 3 is 6. 3 times 15 is 45. 45 breaks down into 9 and 5. The square root of 9 is 3. 3 times 6 is 18.
Holy mother. Okay, cool. Makes sense.
Does anybody need me to break down 5? Or are we okay?
Okay.
So can you handle these tonight? So far you have 2, 4, 6, and 8. You're probably going to have some more. Let's do this.
Wait.
Part 2. Part 2. Now, we have done part 2 before. We have simplified with variables. We've actually done all of this except for parts 3 and 4, like I said a minute ago. So, does anybody remember what the number is in the mullet when it's just a square root?
2.
2. Yes. So the first thing you do is you still do the same thing. You break down 90 into the biggest perfect square that goes into it. So what's the biggest perfect square that goes into 90? Yes, thank God, 9. 9 and 10. I like the collective sighing and groaning to figure that out, though. It was like if y'all were all on the same pitch, it was a little alarming. All right, now what's the square root of 9?
3.
Okay, so we're going to write 3, and what we're going to do next is we're going to leave some space, and we're going to write the square root, and we're going to put the 10.
Okay. Makes sense.
Now, the reason we're leaving the space is why?
Because we got to bring down the variables.
We got to bring down the variables. Now, we have done this. Yes. Wait. Yes, you will. Now, what you do is you see how many times 2 goes into each of the exponents. So how many times does 2 go into 3?
1.
With how many left over?
1.
Now, how many times does 2 go into 4?
2.
Does it have any left over?
Yes.
No, it doesn't.
Oh.
Now let's divide into 5. How many times does 2 go into 5? With how many left over? Does everybody see how I got that?
On a good day.
Now, just in case you don't see how I got that, I'm going to write it down using the letters. We have 3 x's. And we need groups of 2 because it's the square root. So we have one group of 2 with 1 left over. That's why we have an x out here and an x on the inside.
That blew my mind.
All right, how many y's do we have?
2.
We have 4 y's. 1, 2, 3, 4. How many groups of 2 do we have? 1, 2. Magic with none left over. How many z's do we have? All right, we have 1, 2, with 1 left over. That's where it comes from. It's magic. Circle your answer.
The y on x's are 2 is the exponent.
Okay, are you ready for me to explain it again? We have 3 x's. That means we have 1 set of 2, so that's 1
The one is
with
understood.
1 left over.
The one's understood.
Where are you?
I don't know. My hand hurts.
All right, now let's look at B. What is the biggest perfect square that goes into 32?
Nope, 16 and 2.
16 and 2. That's what I'm talking about over there. High five. Maybe you should let some of that rub off on Parker since he's not paying attention and is just messing around.
I'm not touching Parker.
She didn't.
I meant the knowledge.
Well, you said rough.
Maybe you should transfer some of that to Parker. All of it.
Not about that.
Oh, I hate you so much.
Don't swing that way.
Stop. It's still recording.
Yeah.
Okay.
Wait, then why do you have the on-air sign?
Because it's not plugged up because I don't have enough room because I need to be able to move over here. Knowledge. All right, now what's the square root of 16?
4.
And what stays inside to read Harry Potter?
2.
The 2. Does everybody see where that came from?
Yeah.
All right, now let's do our exponents. We start with r squared, so how many times does 2 go into 2?
Is it gonna do
One
every
time. Yes, unless it's a cube. And it'll have a 3 there if it's a cube. All right, how many times does 2 go into 4? Do we have any left over? All right, can we not sound like we're dying? How many times does 2 go into 5?
2, 1 left over.
Wait, hold on.
This should be a 2.
Yeah, that's what I'm thinking.
Thank you, Tyreek.
Oh, yeah, sorry.
I'll play it.
Look at you catching stuff.
Wow.
And put a box or circle or baby Jesus around it, and let's move on to C.
Or a girdle.
Why?
Why not?
Yeah, why not?
All right, C. Yes, sir.
Speak up, please.
Yeah, I don't know what you said.
Yes.
Dinga dinga durgan.
Yes, they do. Yes. In the house? Yes. I'm sorry, I was confused and didn't know, but thank you, Carolina, for having my back.
Okay.
Wow.
All right, now let's look at C. This
4 and 14.
Can you give other people a chance?
Nope. Selfish people live longer. Selfish people live longer. You're not first or last.
We can't take the square root of 14. It's the square root of 4. Is?
2.
And what stays inside to read Harry Potter?
14.
Now, looking at your letters, how many X's do we have? So is he going to stay inside? If there's just one, they stay inside.
Just one.
Alright, now we're going to take this 2 and we're going to divide it into 10. How many times is 2 going to 10? Are there any left over?
No.
Alright, let's divide into 5. 2 goes into 5.
Twice.
Twice, one
With
left over.
1 left over. Questions? We okay? Alright, let's do 11 and 13 real quick. 11 and 13. I'm going to let you figure it out.
Ew.
We're doing on phone.
You're doing 11 and 13.
You said I think 9.
You take the square root of 81.
Understood.
That is 9.
9.
2 goes into 2 how many times?
Once.
2 goes into 4 how many times?
Twice. 5. That's it.
Little confusion for you, sorry, Mari.
That's it. ARF.
AARP.
The square root of 81 is 9.
Is an absolute dead.
Because this is 9 and 9.
So, number 13 would be 5.
I got that.
Look at you go, I'm so proud. Well, I was proud for a moment. What'd you get?
3D squared and then the thing and then 9. No, 9.
Okay, the square root of 81 is 9. So you write the 9. Okay? And that's because, since that's the biggest perfect, 81 is a perfect square, so you just take the square root of it.
Oh.
And then 2 goes into 2 once, so you have an A. 2 goes into 4 twice, so you have D squared.
I put that 3.
If I didn't even get this next one right, I'm cutting off my big toe.
You're coming off of Nutella?
Cutting off my big toe.
That's totally different than what I thought.
I will snap
Stop
my leg.
harassing him.
John,
You need to do your
John,
push-ups.
if I don't get
Okay.
problem correct, I will snap leg in half.
Did y'all get 5 m squared p times the
John
square
got
root of
problem
3m?
correct.
John got it correct.
No snapping leg in half.
Anybody else get it correct?
No.
Did anybody else get it correct without copying their neighbor? Woo!
Come on.
Femur lives. Hashtag femur forever.
Hashtag femur beamer.
Alright, now, here is the, okay, so tonight that adds problems 10 and 12 to your to-do list.
Oh, okay, Blair.
What just happened? 2, 4, 6, 8, who do you appreciate? Asbury! Maybe. Alright, now we're going to rationalize.
Sorry, she blew a whistle.
Now, rationalizing means that you have to stop screaming.
Actually, I will shave you bald.
Alright, so rationalizing means that you're trying to get the radical out of the denominator. Now, this square root is over the entire fraction. You cannot have a radical in the denominator.
What is B?
You cannot have a radical in the denominator. You cannot have a radical in the denominator.
Question, can you have a radical?
So what you do is you reduce. So please write reduce right there. That's the first step we're going to do, is we're going to reduce our
What do you
fraction.
write? Ikuder.
Reduce backwards.
Reduce backwards.
Alright, now what goes into both 15 and 35? 5.
$1 long. Not really, but
35 divided by 5 is
7/3.
15 divided by 5 is? It's not over anything because we're not cows.
Divided by 3, snap femur in half.
I haven't done this in a while.
Divided? We just did it a minute ago.
No, but like, we haven't done the over, you're a cow all day. In a while.
No, we did it. We sang a song about it. And
Yeah,
she
we
told
sure
us not
did.
to say over.
Like last week. We were just there.
That was a long
Tyreek,
time ago.
hit it.
And your test scores reflect that. Here we go.
Does it now?
Now, what you do from here is you break this down. So the first thing we did was we reduced. Now break it down. What I mean by that is you write the square root of 7 divided by the square root of 3.
What the heck is this? Mahogany. Oh, wait, that's a piece of
Now, the reason that we're doing this is so that we can get the radical out of the denominator. So to rationalize it, which is the whole point of what we're doing,
Should be rational.
you multiply
Bye.
the top and the bottom times the square root of 3. The reason we do that is because this is the square root of 3. If it was the square root of 5, what would we multiply the top and bottom by?
Square root of 5.
If it was the square root of 6, what would we multiply the top and bottom by? So whatever is down here, you multiply the top and the bottom by that square root. Now, we just said a second ago that the square root of 3 times the square root of 3 was what?
3.
That's why you can do this, because this then becomes 3 on the bottom. What can we do with that 7 and 3? Multiply it so you get the square root of 21. And you're done.
Wow.
Miss Isaac,
No.
working on.
What?
Porque yo lo digo.
Oh.
Is it about the math?
Sort of.
No.
No, it's like a legit question.
A legit.
What?
You remember that word that Mario said? Like,
Cattywampin.
Cattywampus.
Yes! Sorry.
You're welcome.
That's not about the math.
Oh, it happened in this class. In this math class.
Okay, so now let's look at this one. You can do this one two ways. You can rationalize by multiplying the top and bottom by the square root and then reducing, or you can reduce first because they're both under the radical. So do you guys want to reduce or rationalize?
Reduce.
Reduce, okay. So what goes into both 6 and 12?
3.
6.
12.
12.
How old are y'all that y'all don't know that 6 goes into both 6 and 12?
15.
So 6 goes into both of those, so that becomes the square root of y divided by the square root of 2. Where did that 2 come from?
6 times 2 is 12.
6 twelfths reduces to 1/2. Why do we just have a y here and not a 6y anymore? Because they canceled out. 6 divided by 6 is 1. Now we rationalize. What are we going to multiply the top and bottom by? No.
Why?
No. By the square root of 2. Those are two different things. The square root of 2 and 2 are not the same thing. So what are we going to multiply the top and bottom? Thank you.
Matching Asbury now.
Alright, what's the square root of 2 times the square root of 2? What is y times 2? 2y. And then you're done.
Oh, you got 2 y.
Good, I'm glad.
Okay, then.
Does everybody understand? Now let's walk through it again to make sure. What did we do first?
Reduce.
We reduced our fraction. We divided the top and bottom by 6. And we got this. Can you stop? Thank you. We got the square root of y divided by the square root of 2. Why did we multiply the top and bottom by the square root of 2?
Because you're supposed to.
Why? You can't have a radical in the denominator, so you have to rationalize. That's what we're doing here, is rationalizing. And then, where did this 2 right here come from?
The square root of 2.
Square root 2 times the square root of 2.
Is 2. Good. Where did this 2 come from?
The square root
Square
of
root 2 times the square root of
2 times y gives us this.
2. Got 2 y.
Alright, now let's look at C. Let's reduce that. What goes into both 45 and 10?
5.
Yes.
That's the other way. You said you could either reduce or do the flip. Or
You could rationalize and then reduce. It is much, much easier to reduce first.
okay.
Alright, so what goes into both 45 and 10?
5.
Alright, so that becomes the square root of 9 halves. Now we break it down because we need to rationalize. So we do the square root of 9 divided by the square root of 2.
Okay.
What are we going to do from here? Multiply what? By the square root of 2. Why not the square root of 9? That's your numerator, not your denominator. Alright, what's the square root of 2 times the square root of 2?
2.
Can anybody tell me what the square root of 9 is?
3.
And what's left over? The square root of 2.
Huh?
So if it's a perfect square, you don't multiply.
Nope, you can take the square root of it.
Oh.
So from here, we reduced our fraction. We divided the top and bottom by 5, and we got 9 halves. Then we separated our radicals. We rationalized by multiplying the top and the bottom by the square root of 2. Square root of 2 times the square root of 2 is 2. The square root of 9 is 3 times the square root of 2. And we're done with that. 15, 17, 19. Go.
15, 17, 19. Is that how much?
Right now work.
Gotcha.
So I got the square root of 6 divided by the square root of 6. Yes, no, maybe?
Yes.
This is me trying to explain that 4 cheeseburgers divided amongst 8 people will give you a half. That's why I explained it.
I thought it. No.
Y'all can just say I did a great job and not judge, but that's fine, that's fine.
It's beautiful.
Thanks. Alright, now for 17. For 17, did you guys break it up into the square root of q divided by the square root of 12? Because that's what you should have done. So if you have not done that, do that now.
The hair is so Wait, what are we doing now?
Breaking this apart.
Doing it more.
Remember tree stump.
Breaking this apart. Alright, now what would we multiply the top and bottom now that we broke it apart?
The square root of
The square root of 12. Multiply the top and bottom by the square root of 12.
Yeah, wait till my freshman break. Life is crazy.
Travis, where's lip gloss?
You're 5. Stop. Alright, now what is the square root of 12 times the square root of 12? And what's the square root of q times the square root of 12? The square root of 12q. Alright, questions on that one? Does it make more sense now? Okay. 19. Did you break it apart into the square root of 12 divided by the square root of b squared? Break it apart.
Have a great day. Catch on.
Alright, now, before you rationalize this by multiplying the top and bottom by the square root of b squared,
Ouchie, wouchie, my
is b squared a perfect square? Yes. So you just take the square root of b squared. 2 goes into 2 how many times? Boom, that's your answer.
Oh, I was close.
Close only counts in horseshoes and hand
No,
grenades.
almost. Sorry. So close yet so far.
Does everybody see how I got this? Does anybody not? You don't see? Okay. So I took the square root of b squared. Because 2 goes into 2 once, so we have 1b. And then the square root of 12 is just left on top.
Okay, now I get it. I get it.
Does that help?
Yes.
Do we need to walk through any of these again?
Oh.
Alright, so now your homework extends to
14, 16, 18.
and 20.
Oh, dang.
I'm starting to see a pattern.
Crazy. Now let's look at number 16 together before you leave me. What do you think we would do with these?
Simplify.
You would multiply them.
Multiply.
So you would do 6 times 1, and you would get what?
6.
7 times 3, and you'd get?
21.
Can we reduce that fraction?
Yes.
What goes into both 6 and 21?
2 and 7.
No.
Okay.
So it's 2/7. Now would you break it apart from here?
Yes.
No.
So the
Yes.
first step every time when you have these is break it apart to the square root of 2 divided by the square root of 7. Break it apart. No, we don't know how to do those yet. You have to do conjugates. And that's what we're learning tomorrow. Okay?
Define conjugate.
Yes, you multiply the top and bottom by the square root of 7.
Homework.